Okay, let's do a trig substitution here. In the denominator, I will factor out a 16, and as it comes through the square root, it becomes a 4 in the denominator. And this leaves us with the square root of 1 plus x squared over 16, which I will write as x divided by 4 squared. And we can now do our trig sub. We are going to let x divided by 4 be tangent of theta. If we would like, we can multiply both sides by 4. Not necessary, but some folks find it easier to do the derivative step with x isolated. Up to you. Either way works. So we end up with that. Now, later on, we're going to need a triangle to go back, so let's just draw the triangle now. We know that tangent of theta is x divided by 4, so this triangle will represent the relationship between x and theta, and the hypotenuse will be root x squared plus 16. Jumping back over to the to the integral, we have 1/4 integral x squared is going to be 16 tangent squared of theta. Dx is 4 secant squared of theta. And in the denominator, we have the square root of 1 plus tangent squared, which is secant squared of theta. Some simplification, we see the 4's cancel, and that leaves us with, in front, a 16, and then the integral symbol. And also notice that square root of secant squared is secant, and that's going to take away one of those secants in the numerator, leaving us with tangent squared theta multiplied by secant of theta, d theta. This integral is solved using a Pythagorean identity. Tan squared is sec squared minus 1, so we end up with secant cubed of theta minus secant of theta d theta. Those are both easily integrable. This first one is done using integration by parts. We've done it before. You should know that, or at least know how to do it. So let's go ahead and write down the answer then. So that's going to be 16 multiplied by integral of secant cubed will be 1/2 secant of theta tangent of theta plus 1/2 natural log absolute value secant plus tangent minus the integral of secant. And the integral of secant is also right here. So we're going to have a minus, let's see if I can squeeze it in right down below, minus 1/2. Nope, sorry about that, not yet. I was thinking ahead if we combine our like terms. We'll do it in a moment. So we're going to have minus natural log of secant theta plus tangent theta plus c. And let's get the bracket in there. Okay, so let's distribute our 16 and combine like terms. So this gives us 8 secant theta tangent theta. And then when the 16 distributes over here, what we're going to end up with is minus 8 natural log secant theta plus tangent theta plus c. So we've got that expression. Now let's jump to our triangle and rewrite. Secant of theta is the hypotenuse divided by the adjacent side. Tangent of theta is x divided by 4. And then inside the absolute value we have secant theta, so that's again the hypotenuse divided by the adjacent side. Tangent is x over 4, so we have that. Now let's do a little simplification here. We have 8 divided by 16, which is 1/2. Let's rewrite this as follows. And then here we have minus 8 natural log absolute value square root x squared plus 16 plus x. So what I did there was use a log property. We're going to have log of this numerator minus log of the denominator. Log of 4 is a constant. Log of 4 multiplied by 8 is still a constant, and that can get absorbed into this constant over here. So this will be our final answer.